A large chunk of the information provided in this tutorial comes from the Rust documentation. I will attempt to piece all the parts together. The Impl keyword is primarily used to define implementations on types. Functions and consts can both be defined as implementations. Just to clarify, in Rust we have functions and methods. Methods differ from functions in that they are always connected with a struct, an enum, or a trait object. In reality, you will probably be dealing with them within the context of structs if you are watching this tutorial. What is powerful about implementations is that we can override Rust default implementations and make them do as we want to. I think the simplest example of this would be the drop implementation. Drop is called on a construct prior to being destroyed in memory. So in the code example, when sumOptions2 is being destroyed, the word dropping is printed. Another more common example would be implementing how a particular struct is printed to the screen. You would use Impl format display for point in this case. There is a standard alternative, such as using the derive debug. However, display is similar to debug, but display is used for user-facing output and so cannot be derived. The first time you will come across this in Rust is when you try to print something, or a struct in this case, or you use a feature, and you'll get a compiler error such as "this thing is not implemented." This particular error would look something like this displayed in the white box. I'm sure you are familiar with it. So if you are unfamiliar with that error, you now know what this is referring to. And the good news is that you can implement something to remove that error and use a particular feature. In this case, what we're doing is using Impl format display for the struct point. And what that does, it tells the compiler or the program how to actually print the point struct to the screen. Here we have another implementation of the example struct. To be clear, the way implementations are used in Rust are as follows. You create either a struct, enum, or trait object. Then, based on that object, you create particular methods. This differs from using a direct function, which can be created independently of a struct, etc. The powerful thing about using implementations is that you can change the way the Rust standard library acts. A common example would be implementing your own iterator. In this case, we have the counter example from the Rust documentation. Firstly, the struct counter is created. Then we implement the new method so that this is initiated by the counter and that the first value is set to 0. Finally, we create the next method, which is the only method that we need to define in order to create our own iterator. In this case, it counts to 5 and then returns none after that. The beauty of this is that all the standard iterator methods are now available for us to use on our counter type. This is very powerful, and it also gives a good example of the power of traits. The output from the counter example is given in the test, which is now displayed. I hope that you found this tutorial useful. As always, the code is available on GitHub and the link is displayed in the description. Thank you very much for listening.